Right. Hi all. My name is Mechiel, lukkien. I wrote MOX, a modern all-in-one email server. So today I'm going to talk a bit about MOX, tiny little bit about email, a few Go things and a few generic software engineering things. I have way too many slides, so I'll just cut off somewhere halfway. If you have any questions during this talk, just ask them. I always like a bit of interaction. One of the cool things, of course, of MOX is that it is completely free. You can download it for free, use it for free. You can get the source code for free on that GitHub URL, and you can make changes for free. So keep that in mind. So a bit about myself. As I said, my name is Mechiel lukkien. I am a freelance programmer, hacker, software engineer, developer, architect, whatever you want to call it. I studied computer science quite some time ago. I'm a Go enthusiast since the very beginning, and maybe even before that, because I've been programming quite a lot in a programming language called Limbo, which came with an operating system called Inferno. Has anyone heard of Limbo and Inferno? Yeah, oh, I see one nod. Okay, that's good. So you may know Plan 9 because it's one of the supported platforms for the Go toolchain. So Inferno was actually a successor to Plan 9. Plan 9 was a successor to Unix, and Unix is a system we're all using today. So I'm also one of the organizers of the Go meetup in Amsterdam, which is also very cool. If you ever want more meetups, you can go come visit us in Amsterdam, and we'd like to come here as well. So thanks for having us, or having me at least this time. When I'm not doing computer stuff, I like to go outdoor and do things. Last year and the year before, I made some cider, and I've grown shiitake mushrooms, and I'd like to do more of that kind of stuff, just to get a bit outside of the computer only habit, which I've been doing for a long time. So the topics for today: MOX, why did I make it and what is it? Some email basics, just a refresher. I hope you know a little bit about email. Then I'll show you a little bit about MOX. It's a server thing, so it doesn't really, there's not a lot to see, but there's at least something. Then there's a quick start to easily get you started with MOX. Then there's a little bit of Go stuff about testing. Then a generic software thing about cross-referencing your code with specifications to keep your code maintainable. And I think that's when I passed the half-hour mark. So the other topics are very interesting as well, but time is limited. So first, MOX. Why did I make it and what is it? So email. I think we all use email. I'm wondering who is hosting their own email on their own domains? Okay, maybe 25%. Is anyone hosting their own mail server? Okay, quite a few. Nice. Space for improvement still, but I've also run an email server for a long time. I've used Postfix and Dovecot and a whole bunch of other tools, and it works. But there's a problem with it, and that is it's many components that have to work together. Because over time, email grew. In the beginning, like in the 80s, it was simple, but components, protocols, anti-spam mechanisms have been stacked, and now you have need a whole bunch of tools together to get one working system. So I've seen people, and I've felt this myself as well. At some point you think it's too much trouble, I don't want to do it anymore, I'll just go to one of the big cloud providers, to the Googles and the Microsoft. But no, if everyone is doing that, then email is no longer decentralized. That's one of the cool things about emails, it is a decentralized protocol. Anyone can run their own mail server. So everyone's all happy with their decentralized blockchain, blah, blah, blah. But email is also decentralized, and we just have to keep it decentralized by running our own mail servers. So MOX is here to make it easier to do just that. So that's one of the goals. Take back control of email and keep it decentralized. And one way of doing that, of course, is to make it easy to use. And that's now also one of the primary goals of MOX, just to make it easy to use, easy to get started, easy to maintain. So some things that I have done. So one of the things is it's an all-in-one mail server, so just one component. There's no other dependencies. You don't need a database server or whatnot. It's just this one thing. It's a standalone binary. Of course, Go is helping here because you just compile your Go program in a statically linked binary, just one thing. There's no libraries you need to have installed or something. There's a quick start, which can get you started with MOX in 10 minutes. Then you have a completely modern configured domain. You've got TLS nowadays with ACME automatic certificates. MOX does take care of all of that for you. It's configurable through a web interface, very easy, anyone can click around a bit, but you can also do the CLI in the config files, which I find important. There's self-checks about the health of the system. Oh, I have to go back here. And you can get notifications about new releases, because this is email, I can just deliver something in your email box when there's a new update, only when you enable it, but I always recommend you enable it. So this is a modern, new, fresh, coherent code base, only 46,000 lines of code, excluding dependencies, and 30,000 lines of tests. And the dependencies, most of them I either wrote myself, so it's not really that external, or they are the golang.org/x dependencies, so they are from the Go team, high quality dependencies. And then I mentioned this before, there is a Prometheus dependency which is quite large, but it's in there as well. Right. MOX and anti-spam. So you can have a mail server that's one component, and that's easy to use, but if you have no anti-spam mechanisms, then you're still not good enough, because spam is, of course, a big problem in the email world. So you need to address it. And MOX, of course, has mechanisms to prevent spam from coming into your mailbox, and some are a bit different than what you're used to in other mail systems and in the online mail providers. So one of them is MOX doesn't deliver your email or incoming email to a spam box. So this is something that Gmail sometimes does. You send someone an email, Gmail says, okay, I've delivered it, but it put it in a spam box, and the person is never responding because they never actually saw your email. So I think it just erodes trust, and I don't want to do it with MOX. I understand why they do it. They don't want to give spammers the signal that something looks spammy, because then the spammer is going to change things. But at the same time, it makes email less nice to use. So I don't want to contribute to that same problem. So what MOX does, and this makes sense at some point, if you have a conversation already with people, you can keep receiving and exchanging emails with those people without much spam filtering, because once you accept email from someone, clearly there's a relationship going on. And in MOX, as soon as you mark an email as spam from someone, then future email from that person will be blocked because it's spam. And it will be blocked nicely. They will know that the email is not being delivered. But this really just makes the tricky part, or the part where MOX can be strict, is when you first send the message for the first time. So the first time you communicate with someone, MOX can be very strict, do additional checks, strict content filter, junk filter. Not having, so what many large providers do is they just have an IP block, and if you happen to be on that list, yeah, you're out of luck, even if you've communicated with people at, say, Gmail for a long time. There's another thing that MOX does, if email is rejected, it is still stored in a special mailbox, and you can still access it. So if you say you sign up to some website and they send you a confirmation email, but it doesn't look very spammy, then it's blocked. You cannot log in, but you can look into your rejects box and still take the message out and put it in your inbox, and then the communication channels are open. This helps with the real time you're waiting for it, the false positives on the spam filter. Also means you can make the spam filter a bit more strict. And MOX only uses IP block lists for suspicious first-time senders, so only if it's really needed. MOX does it for every connection, for every email it receives. Go talk to some centralized list, give them the IP that you're communicating with. So it's privacy preserving, and it keeps email decentralized. All right. Email basics. Any questions so far, by the way? No? All good? So, email is nowadays quite complex. In essence, it's pretty simple. You have a message, and you have SMTP to send the message, and then you're all happy. Maybe you have to retrieve a message. But nowadays, if you want to do email, you need to do SMTP, DNS block list, junk filters of various kinds, SPF, DKIM, DMARC, TLS with ACME, MTA, STS, DAME, TLS reporting, IMAP, and in the future also JMAP. Then that's a whole bunch of specifications and protocols, and then there's internationalization, which makes everything that used to be 7-bit, makes it UTF-8 Unicode, and that makes everything, again, much more complicated. Then you want to have auto-completion, so your email clients are easy to set up. So things get very complicated, or rather, very large. Luckily, everything is pretty well documented in RFCs, so it is doable, it's just quite a bit of work. So, refresher. Email basics, email messages are just text. You can open them, view the source of your email message. Who's never done that? No one's never done that. So the message starts out with a bunch of headers, then you've got an empty line that separates it from the body, and then there's the body, and that's pretty much what the message is. And if you want to have inline images and HTML as well as text, use mine, and then you can still make textual files that just have more content in them. But this is very, in the essence, pretty basic. And then you deliver it with SMTP. So you look up, you want to send to an email address, you look at the domain, take its MX DNS record, and you will find the hostname to connect to. You connect to port 25, and you get a banner, and you send your hostname, send its extensions that it supports, you tell it that you're sending from a certain address, so envelope from, so I brought an envelope, yeah, this is the envelope from, go back, and then you say the recipient, the message is going to a certain person, all fine, and then you're going to send the message itself, the data, yeah, so that's inside this thing, yeah, you have the to, the from, so you have these two separate things, and then you end with a dot, and then it's being rejected because of anti-spam measures. I did this from my laptop, and it's not allowed to send email from this message address. So this gets complicated, can get complicated, and it does get complicated in practice, because the envelope from and the message from don't have to match, and there's all kinds of expectations and possibilities to abuse message sending, by pretending to be someone, etc. And there are all these newer protocols like SPF, lukkien, are helping to prevent abuse. All right. Quit. Go away. All right. Then, to show you something of MOX, because there's lots of talking about MOX, we haven't seen anything yet. Let's start with the boring commands that MOX has. So you just serve. This is what you do. You serve a mail server. Of course, that's not interesting. You can do a quick start to easily get started. And manipulate the queue. Use the messages that still have to be sent. Import email into your MOX accounts, export email. Local serve is for starting up a mail server locally for testing. So say you're developing an application, you need to send email, and start up your local MOX, send email to it, and then use IMAP to read the email from it. And it's all local, there's no server needed, so it's a useful development tool as well. Then there's help, which can print information about all the help commands. And what I do is I generate all the help at build time and put it in a Go doc, so the public package has all the documentation and all the commands documented, so I don't have to write a separate website to do that same stuff again. So it just helps me prevent work. Now there's a whole bunch more, and also for each of these protocols we have subcommands that allow you to work with email messages and so on. So it's also pretty much a Swiss Army knife for all these email protocols. What I find when I write Go code, the functionality often, it's in a package, it's often very reusable, so I don't have to do much work to put it in commands like this. It just sort of happens automatically. And then there's also admin interface. Yeah, there we go. Log in. It's very basic, no flashy whatnots, just text, links. I'm not going to go through all of this, but there are accounts. You can look at the outgoing queue, you can check your domains, you can look at the reporting, so you can get all kinds of reports about email back, and you can being collected and processed, and you can look at them. And look at the DNS blocklist status of your IPs. So you don't want to be blacklisted, of course, your IPs. You can send email to other mail servers. And there's a web server inside MOX. There's a story behind why that's a good idea, but I'll leave it for another time. Inside, you can basically configure pretty much anything. Well, you can configure a lot of the things you can do in config files across the web interface. I don't want to go into too much detail. Then the quick start. So, say you have a new Linux machine and you have a domain. You want to set up MOX. You run the quick start with your desired email address right there, and it will do some checking of the IPs of the machine. They're properly configured with DNS, that the IPs are not in the block list. Then it will print passwords, generate passwords. It will generate passwords and print them, so you can use them to configure your email clients right there. It writes config files, and then it prints a whole bunch of DNS records that you need to add to your domain. And if you do that, you start it, you've got a working system, and it even does, down here, it will automatically set your file permissions and ownership correctly, and it will create a service file and get your own Linux, and it will just print commands that you can copy paste to get a system Unix service started. So you can really get started with the 10 minutes of download it to a new system. Right, running some Go stuff. Testing. So MOX has a lot of tests for lots of scenarios for sending email, etc. There are integration tests. It fires up postfix, SMTP server in a Docker container, sends email to postfix, and makes sure it gets back. Checks that works correctly, so it is not insufferable. There's fuzzing. So SMTP and IMAP server are being fuzzed, so I just start the fuzzing. Fuzzing generates random commands and will write those to a server connection. And then I check that the server doesn't die in weird ways. So it's just really spraying commands around and seeing that nothing breaks too badly. You can have a quick look. So if you have not done any fuzzing, it's really easy to get started. This is for the SMTP server, and it is just barely 114 lines. So you start a fuzzing just like testing. You start with the fuzz function. You get with the testing.f. Here, this is just seeding the random strings that it will try with a bunch of SMTP commands. So at least it will try also some reasonable SMTP-like things. And this is all about setting up MOX itself, so it works correctly. Ignore it for now. There's some log file handling, you can ignore it as well. This is the actual fuzzing. So this func is being called all the time with new S's. It's not random because it's smart in what it picks, but it's just completely different values of S all the time. And this is, I use it as a command, now send it to server connection. So this is all done in this run function. So just set up two sides of the connection with network pipe. So they are network connections. Just if you write in one hand, it comes out the other, and vice versa. So it's just like a TCP connection. It's a drop-in for a TCP connection that you use for testing. And we've got this background Go routine that writes commands to the client side. And we have here, this is a serve function, and this is handling one connection. So client is writing commands into the connection, the server is processing them. And we do this for this randomly fuzzed input. We do this several times. So we do it once on a new empty connection. We also do it once on a connection that's been initialized with this first ALO command. So that means that the connection has transitions to the next state and is open to different kind of commands. Do it again with the value email from, and then again with the recipient to. So different states of the connection, so reaching different functions with fuzzing and this random string. And if there would be some kind of panic, a nil pointer dereference or out of memory or whatnot, that would be caught with this test. So then I can show you quickly. This is very good. Enormous. It's not really enormous. So running the tests, all these separate packages, they have pretty good test coverage, and that's something that's so great about Go. These tests are just like regular Go, so you get the fast compilation, the fast tests, you get the coverage output. Very happy with how you develop in Go. Then cross-referencing code and specs. So email has all these different protocols and mechanisms, and they're quite including extensions. So in the end, it's quite a lot of specifications. And then when you write your implementation, it's kind of tricky to keep the two in sync, or it's also tricky to know that the implementation handles all the special cases that are that you should handle according to the spec. So what I've done is cross-link the implementation with the RFCs. So let's have a quick look at what it looks like. Yeah. All right. Open it up. So here's that serve function. So this is the SNMP server. This serve thing handles one connection. It has too many parameters. It's not pretty. You can skip the first part. Just press some special test unlocking. Then exit connection. That's stuff for logging, tracing. But I want to go some cleanup. I want to go here. So this is the first part that actually does something in this function, or that starts handling the connection. So it starts by checking if we are shutting down. So if you're shutting down, connection that's done thing, this context will be cancelled, this done channel will be closed, and this statement will be run, and it will just write to the connection from shutting down, and with this error code 421. So these are 3 references to RFCs. So this is just a file. So one directory up, RFC, this is RFC 5321. This is the line number. This is pretty much standard Unix syntax for referencing a specific line in a file. And if I open this, it opens the file at a specific line, and it says something indeed about this 421 status code. That the service is not available, and that this may be a reply to the content if the service knows it must shut down. So now when I read this code, and I don't know why I wrote this shutting down stuff, I can just go here to the RFC and see it immediately. And not only that, you can also, fixed with for you. You can also see these other references. So some other place in the code also references this same line in the RFC. So this one points back to here, but there's also another place in the code that is about shutting down. And indeed, this is the function that handles individual commands. So at connection startup, we check this. For each command, we also check it. So now when I read the code, I can quickly jump to the RFC. And when I'm reading the RFC to see if I'm handling stuff correctly, I can go to see at the end of the line if there's any code that handles that part of the specification. And this works nicely in RFCs. So I only edit the RFCs. RFCs are always maximum 80 lines, or 80 characters wide. So I can always just go beyond 80 characters and add some more references to it. So this has been very helpful for me in when writing the code to know that what I'm doing is indeed still correct. Because it often happens, so you look at code you wrote 6 months ago and you have no idea why you did it like that. This helps quite a bit with that. Before we run time, maybe I can still say a little bit about this storage in MOX. So in MOX, email messages themselves are mostly stored in the file system as separate files, like a mail dir, if you're familiar with that. But we also need very fast access to metadata. That's for the spam filtering mechanism. Because the connection comes in, tries to deliver an email, a bunch of things have to be checked against historic messages, whether they were spam, so it knows to reject or accept the message. So we need a fast and consistent and transactional database for all these fields, like the SNMP envelope, and the message from and the message to, and whether the message was marked as spam by me as the user. So what I initially did in the first prototyping was use SQLite, which is pretty cool because it's a very high quality, very fast database library that you can compile into your code. You still don't have any external dependencies, but you do have a complete database system inside your application. You can make complicated or advanced queries with SQLite. So that's good. But there's a big downside to it, that SQLite is written in C. So you're using C Go. So that makes it harder to cross-compile your application. It's possible, but it's quite a bit harder, and it's also hard to reproducibly, which I find a good feature of software. That means you get the exact same binary byte for byte if someone else compiles it. So I wanted to get rid of SQLite, so I wrote bstore, which is a new database kind of library that you can compile into your code, which is only Go, and so there's no more C Go. And the good part about this is that I wrote it just for Go, so it really fits in the Go ecosystem and Go way of doing things. So in Go we have 0 values, so that's used in the database library. You don't have a separate data definition language like create tables and so on. You just have the Go types. You add a few struct tags, and then suddenly you have a database, pretty nice database system. So this works. And there's a Go query API. It's certainly not as advanced as SQL statements, but the stuff that I needed can be done with this. So the basic stuff can be done. So this is built on top of MolDB, which is a key value database store. And I have more details here about bstore itself. So as I said, Go types, struct types that you store, basically tables. This is, you don't have to create them explicitly, it's just done automatically. Every type has a primary key, so simply the first field is just a primary key. So often you just have an ID field, which is an integer or something. Which is also ultimately auto-incrementing. So if you try to insert the 0 value, it will assign the next 3 ID. There's referential integrity, so if you have 2 types and one points to another one, then it's actually checked by the database library if you insert one with any reference that this reference exists. And that's certainly an important database feature. Then for performance, there's indexes that are maintained automatically. You can add constraints, non-zero constraints, unique constraints, also over multiple fields, including the index. You can have multi-field indexes. And the schema management is automatic, mostly automatic. So if you add struct tags in a new version of your Go code, the next time the database opens, it's automatically, schema is automatically updated and checked with the new constraint. Basic gets insert, update, delete methods, and a basic query API that uses generics in a somewhat useful way. So it was built for Go, and it was built on top of MolDB. One of the cool things about MolDB is that the databases are a single file, so truly a single file. With SQLite, it's also a single file, except it also has these write-ahead logs or the other one, there's another journal file that you could have. MolDB has transactions, so read and write transactions, multiple reads or just one write. So, okay, that's a bit limited. It's a key value store with multiple namespaces, and namespaces can be embedded, so they are called buckets. And this is what bstore uses. Every table gets its own bucket, and every index is inside a bucket. So, and it's all transactional, and it's high performance. It uses a memory map. Can also have some issues, but it's pretty fast in practice. Well, I think, should I look at examples? I can open a bit of, yeah, that's it. So, we're here in the MOX code. Store directory account.go has the type message struct. So this is the message and the metadata of the message, incoming email message that has been stored. You can read. So, we've got this first field, the primary key. ID is automatically incrementing, so it will always be assigned automatically. Then we've got a UID, which is an IMAP concept. It's also just a number. It has to be non-zero, so you cannot insert 0 value. If you try it, you will get an error on insertion, so it's enforced. Then there's a mailbox ID, because if you have an account, you have many mailboxes in them, and a message has to be in one of these mailboxes. So it has to be non-zero, has to be, there has to be so the combination of mailbox ID and UID is unique, meaning every mailbox ID gets its own set of UIDs. And then there's an index on mailbox ID and received make lookups fast. And then there's the reference to this mailbox type. So if you point to a mailbox, then the object has to actually exist in that mailbox table, and this is enforced when you try to insert something, or so when you try to remove something from mailbox. So you don't have to do anything yourself. Pretty much like you would use. It's the case when you use a normal database. So many more fields. So received as a default now timestamp. So if you insert the 0 value of the time, you automatically get current time, so as its own index. Then for checking the reputation of sender IPs, we don't just check for single IP, but also of the subnets. So we have several maskings of IPs, and we have indexes on those, along with the received timestamp, because we want to look at the most recent 10 messages that came in from a certain IP. They're all spam. The next one's also being marked as spam. They're all good. We're going to accept them probably. And all kinds of information about the envelope fronts, from in this case, and the message fronts. I guess this is. So in the end, you just write your regular Go type. You add a bunch of struct tags, and you've got database storage, transactional, and automatic schema management. So this has helped me quite a bit with development, although I did have to spend 1 month writing this full time. So after that, it was great. Question, yeah.
Have you also looked at Badger DBs instead of Pool DB?
I probably looked at it for a brief moment. I've been asked the question before, I think. There was maybe something that about write transactions between hard transactions or something.
Yeah, it's also related to memory use, but it's also entirely with Go.
Yeah.
But I was just wondering if there was an.
Yeah, no, I didn't. I had a quick look, and I picked this and I went with it.
Question. Is this vStore related to the generic library now, or it's MOX?
This is generic library, so it's a separate thing, but it's not tagged yet, so I'm still doing a bit of development on it. So it's not. I am still also careful when I make changes, but I also used it in another project where it was very helpful. So you can definitely start trying it. It's on a similar URL as the MOX project, but then replace MOX with vStore and you've got it. Okay, so
in the IDs, why don't you use unsigned messages? You show the code.
Yeah, no good reason. I think unsigned messages is probably better. Yeah. So yeah, I think I even put a recommendation in there somewhere that you should probably use explicit with integers, not just int, but int 32 or uint. Makes more sense for those numbers. But yeah, many things to improve still. So so if you want to use a database, either create a new one or open an existing one, you just have the vStore package that you've imported. You call open on some path. That's the file that stores all the data. You give it some options like a timeout, because if it's locked, there can only be one opener at a time. So if it's locked, you will get indefinitely. But with a timeout, at least you will abort after 5 seconds. This is something that's coming from VoltDB. And then after that is a whole bunch of types that you are going to register and use in your database. So once you do this, it looks at the types and the struct tags, creates the tables, possibly updates the schema. If there are, for example, new non-zero references or constraints, it will check those. So it does all that schema management automatically for you. There's a final thing about automated query. This is a little bit in the SMTP server where we check for incoming messages if a certain sender has not been sending way too many messages, because we've rate limited them maybe. So what we do is we check the count of incoming messages from a certain sender. So we've got this vStore package again, create a new query. This is a function call on the transaction. And this is the generic parameter. So this query operates on messages, it will return a message. So this is the base query, and then we add some filters on top of that. So any non-zero field in this message object that we got here, the non-zero field will be filtered on. So if there's like check so this one checks for the masked IPs. So this is the non-zero. This is one of the non-zero fields. This query will not filter on that, and we also filter on received, that has to be received in a certain time. Now we count how many messages we got. So there's no query language, but there's this simple query API store. And I think I'm way over time already, so I'm going to leave the, even though this next project is also very cool. We have to look at it later on. So let's get to the end. The conclusion, of course, is making MOX makes it easy to run your email server, and you should definitely give it a try and start hosting your own email. So just go to my GitHub page and take back control of your email. You will be centralized. We have -5 minutes for questions, but I think we can take one, right?
Yeah, good. So I'm not hosting my own
email
server, but I heard that ours is actually, I don't know, quite hard to do it, because if you send, basically spammers killed all those custom email servers, because once you use your own and try to send someone, say to Gmail or to some big mail server, then it will just automatically reject it, because it just doesn't trust any custom personal email servers.
Yeah, no. So earlier I had my talk was even longer. I had slight objections, and this is that's certainly one of the objections. But it's pretty much impossible nowadays to run a mail server. It's not that bad. You can certainly still run your own email server, but you may run into some issues sometimes. But I have not been running into these issues a lot. That said, just a few days ago, actually I think it was a few weeks ago when it started, Microsoft blocked my new IP, and Microsoft is really bad with this. Well, there are two Microsofts. There's the Microsoft Enterprise, which is
365.
Yeah, that seems to be reasonable so far. And then there's the Outlook.com and Hotmail.com, and they just block everything. So I didn't actually have a problem with that, because people don't want to receive my email. I consider their problem. They have a shitty, they picked a shitty email provider. That's not my problem. But my father-in-law started using my mail server, so I had to make it work. And after some interaction with Microsoft, where they said nothing is wrong with your IP, suddenly it did start working again. So sometimes you may have to send like a request to a party. But so, for example, Gmail, I've never had problems with that. It does also matter that you shouldn't really go to the cheapest, crappiest hosting provider for your server, because these hosting providers, they have their IP space, and if they don't care about their reputation with the email providers, and their customers send it on spam, or their whole IP ranges will be bad. So then it will be impossible. I'm at the Dutch hosting provider Mechiel, and they've had serious issues. Only very brief ones. And I've actually so I get notified when my IP is on a blacklist. So sometimes my IP is on a blacklist, probably because from Spamhaus, for example, probably because something happened, but it's always resolved within a few hours. So for me, it's never a serious issue. So it's doable.
But do you actually know if you send an email to Microsoft and it gets rejected? Do you actually get the info that?
Yeah, in my case, I did get it back. Yeah, that was the fun part. Yeah, I got it. So during delivery, so at the first delivery attempt, I got a permanent error message back, 550 permanent error, cannot be delivered. Your my IP is quoted there, is on a block list. So it was pretty clear. So I sent an email to Microsoft. My IP is on your block list. How do I get off of this? And they responded with, no, your IP is fine. So I don't know what's going on with those people, but. I just asked them a few times more. Suddenly it works again. So it can be magic. But so it can be annoying if you're trying to send email to someone important, it doesn't work. But the important people are probably not on your hotmail.com now, so should be fine. Otherwise, there are other ways. But this is exactly the reason why we should keep running our own email server, because we all give in, we give up, and then we soon only will be able to get email over gmail.com.
You can buy a whitelist license at Microsoft for 12,000.
That's a good tip, yeah. Yeah. Can we have another question?
Yes.
Yeah.
What is the load that this thing can run on? Does it usually visual big for server and 10,000 emails a minute, or is it like?
I've not tried that, so I don't think it should not be very resource intensive, but I should actually do some benchmarking at some point. But it doesn't. I mean, it's written in Go and it doesn't do anything strange, so it should go quite far.
And then Go there's testing.b.
Yes, yeah. So, I mean, so for example, I added these in the database library. I added these indexes so that even the incoming emails can be checked quickly, because you can get intents pretty quickly. I've not optimized anything for performance, so there's probably. I think it can already go quite far, but after optimization, it will certainly be able to get far. But there are still quite a lot of limitations in MOX, so I still have lots of work to do. I have been using it since February, I think, and the transition was smooth, and afterwards I've been using it very happily. So. And I used to have post-fixing Dovecot and a bunch of other tools, but with MOX now, I didn't have a proper spam filtering solution before, but now with MOX I get way less spam. So, I'm happy to have switched.
Do you process emails sequentially or
No, concurrently I can. So there is also a rate limiting on IPs. So one sending email server can send the incoming mail with multiple connections to a certain extent, and then you're held off with a temporary error. So. And outgoing as well. When I would send all of the email, I would do one at a time to one domain, but then I think 10 concurrently to different domains. But this is all very untuned, and because I'm sending email at human rates. So I just have 3 users on my mail server now. So we are 3 humans at human rates. Doesn't go very quickly. Yeah. Right. Thank you for your attention, and I hope you'll try MOX.
Thanks everyone.
What is
I want to welcome the speakers